This is the part 3 of one-dimensional motion. In the last session we discussed displacement and distance. To make the concept clear, we take an example and we will try to understand the difference between displacement and distance. In this example, a space aircraft is moving towards the sun. At time t1 it is at x1 is equal to 3 into 10 power 12 meter relative to the sun. Exactly 1 year later it is at x2 is equal to 2.1 into 10 power 12 meter from the sun. After 1.5 years it is x3 4.0 into 10 power 12 meter from the sun. Find the displacement distance traveled. It is clear from the example that initially the aircraft was moving towards the sun, later its distance has increased, so it has started returning back. Before discussing this, what is the method for solving such problems? First, we have to visualize the problem. Second, locate the reference point, apply formula. Here we have to visualize the problem. The spacecraft is moving towards the sun. It is at x1 something at the starting, then at x2, then at x3. Distances are x1, x2, x3 are located as per the distance given in the problem. This is our visualization of the problem. Second, locate the reference point. As given in the problem, the various distances are related to the sun. So we take sun as our reference point. In the first part we have discussed that for one-dimensional motion or any physical problem we will take different bodies as a point mass. Point mass means body with nil dimensions, but it may have mass or weight. Here the sun is considered as point mass and the spacecraft is moving towards the sun, which is also a point mass. Now problem. The final position of the aircraft is given at x3, initial position is x1. As we know from the formula, displacement is delta x is equal to xf minus xi. xf is x3, xi is x1. We can easily calculate the displacement by this formula. Now distance. Aircraft has started from x1, moved toward x2, then towards x3. This is the total path length and this is the displacement. So you can see the distance is much greater than the displacement. Displacement is change in position, final position minus initial position. Distance is total path length. Now we move on to introduce average velocity. For a one-dimensional motion, average velocity is defined. V average is equal to delta x by delta t. Delta x, as we earlier said, delta is change in position. Delta t, time elapsed. Delta x is a change in position is equal to displacement. Delta t is time elapsed. And average speed is total distance traveled by time elapsed. In velocity, here the numerator was change in position. In average speed it is distance traveled, and that is the distance and displacement. If we take it as a displacement, it is average velocity. If we take it as a distance, it is average speed. Time is a scalar quantity. Now we move on to introduce a basic graph functions. First we take position time graph. In the ICSE syllabus there are various graphs which are required to be understood, such as position time graph, velocity time graph and acceleration time graph, and various methods to deduce velocity and acceleration from the graph. I here introduce very simple position time graph and basic understanding. Later on we will go on to understand the slope of the graph, what is secant, what is tangent, so that various terminologies such as displacement, instantaneous velocity, instantaneous acceleration may be understood easily. Here we have position time graph. Suppose a car was at rest at time t is equal to 0, position is 0. At time 1 second, car is 10 meters from the reference point. At 2 seconds, car is 20 meters from the reference point. At 3 seconds, it is 30 meters from the reference point. We want to plot time, position time graph. So we take two coordinate axes, x and y. Normally, x-axis is chosen as the independent variable and y-axis is chosen as a dependent variable. You may not be able to understand what is independent and dependent variable. However, in this case, time is taken at the x-axis, position at the y-axis. The dependent and independent variables you may be able to understand at later part of in the class 9 when you take up the coordinate geometry in mathematics. So at 0 time, position is 0. At 1 second, position is 10. At 2 seconds, position is 20. 3 second, position is 30. So we have 1, 2, 3, 4 points. We will join the line. This is our position time graph. This is a straight line.